Welcome to our lecture on antiderivatives. A function, capital F of x, is an antiderivative of a function, lowercase f of x, when f prime of x equals f of x for all x in the domain of f of x. We can say this in words. If we take the derivative of f of x, we should get f of x. This is one way to check our work. So this theorem says that if f of x is an antiderivative of f of x, then the most general antiderivative of f of x is big F of x plus c, where c is a constant. Any two antiderivatives of f of x, then, differ only by a constant, as illustrated in the next example. So looking at these three examples, the functions have the same x squared in them, but different constants. But if we take the derivative of these functions, we're going to get 2x in each case. Even though they started out as different functions. So when we start talking about antiderivatives, they're unique up until a constant, and we need additional information to figure out what the missing constants are. So there is a power rule for antiderivatives, just like there is for taking derivatives. So if you have f of x is equal to x to the n power, then the antiderivative, big F of x, would be x to the n plus 1 divided by n plus 1. So let's apply that knowledge to figure out the antiderivative of f of x, and we'll call that capital F of x. So we take the constant 3, we write it down, then we raise the power 4 by 1 to make it a 5, and then we divide by 5. Let's do it to the next term. Raise the power up by 1, that makes it a 4. Divide by 4. Raise the power up by 1, that makes it a 3. Divide by 3. Raise it up by 1, that makes it a 2. Divide by 2. And when you have a 10 with nothing beside it, just a constant, you're going to raise the power up from x to the 0 to an x to the 1, so that would just be an x. And then we write a plus c at the end. Now, at this point, let's check this and see whether we agree that if I took the derivative of the antiderivative, I would get back to f of x. So the derivative of 3/5 x to the 5th is just 3x to the 4th. So the derivative of minus 2/4 x to the 4th is, that would be 1/2, so 1/2 of 4 is minus 2, so minus 2x cubed. The derivative of 8/3 x cubed, so multiplying by 3 would cancel that 3 in the denominator, so we would get 8x squared. The derivative of 3x squared over 2, if I multiplied by 2, the 2's would cancel, and I get 3x. Derivative of negative 10x is negative 10, and the derivative of constant is 0. So we verified that if you take the derivative of the antiderivative, you get back to the original function. Right now, let's look at the next one. First, we're going to write f of x as 8x to the negative 4, and this one 2x to the negative 6. So now we'll apply the power rule for antiderivatives to find the antiderivative big F of x. So we raise the power up by 1, so that makes it negative 3, and divide by negative 3. Raise the power up by 1, that makes it negative 5, divide by negative 5. So that gives us f of x is equal to negative 8 over 3x cubed, negative 2 over 5x to the fifth, and then we have our plus c, which we put on the end. Now, if I wanted to check and see whether the derivative of the antiderivative brought us back to this, we can use this form of it here. If I multiply by negative 3, it'll cancel that negative 3, drops it down to negative 4, I get back to this. If I multiply by negative 5, it cancels this negative 5, drop it down to negative 6, and I get back to this. The derivative of a constant is 0. So we've shown that the derivative of the antiderivative gets you back to the function. So we also know something about derivatives of trig functions and exponential functions and inverse trig functions. So let's take a look at some of those antiderivatives. So if I have f of x is equal to 3 secant squared x minus 5x, I know that in order to get the secant squared, I would have had to take the derivative of the tangent of x. So I go back to my knowledge of derivatives to determine that my antiderivative would be 3 tangent of x. On the next term, I can just use the power rule for antiderivatives, raise it up by 1, and divide by 2, and then I would have my constant. Next, I've got a sine function. So in order to differentiate a trig function and wind up with a sine function, we would have had to start out with a cosine function. And when you take the derivative of the cosine function, you get the negative sign. So that's where that negative came from. So we don't need a negative here. But we do use the power rule when we're taking the derivative. So if we were taking the derivative of the cosine of 2x, we would have to multiply it by 2. So in order to get rid of that 2, we have to put it here. So you could check that if you take the derivative of 3 cosine of 2x, you should get back to negative 6 sine of 2x. So the derivative of the cosine is the negative sine of 2x times that 2, using the chain rule, will get you back to negative 6 sine of 2x. So we've got this correct. This would be 3 cosine of 2x. So we had to divide by 2 to counteract the chain rule. For the next term, we'll just use the power rule for antiderivatives, raise it up by 1, and divide by that same number. So plus c. So this is f of x, the antiderivative. So we can simplify that a little bit. That would be equal to 3 cosine of 2x plus x cubed plus c. So as you're working these, you want to double check your work, but using your knowledge of derivatives to make sure you're not missing something like a constant or getting the constant in the wrong place. All right, and that can happen with these especially. All right, so now going on to the next one, I've got an x in the denominator, and what we know, how we get that form when we take the derivatives, if we start out with a natural log of x, because the derivative of 8 natural log of x would be 8 over x. All right, so we're using our knowledge. Now the next one, we've got e to the x, so we know that the derivative of e to the x is e to the x, so the antiderivative of e to the x is also e to the x. And then we have our constant. All right, in this last one here, this form of the function, if you see that 1 plus x squared in the denominator there, we've seen that when we take the derivative of the inverse tangent of x, we end up with this form, 1 divided by 1 plus x squared. So if we're trying to find the antiderivative, we want to go back to that form, inverse tangent of x. So this would be 5 inverse tangent of x plus c. And to check that, we would ask ourselves, what is the derivative of the inverse tangent of x? Will it take us back to this? And we can look over here and see that it would take us back to this form. So this is the antiderivative of this function here. Next, let's talk about initial conditions. Initial conditions are used to find the constants. In the next chapter, we'll refer to the constants as constants of integration. So in this problem, we're given f of x is equal to 4 secant squared of x minus 6x squared. And then we're given what we call an initial condition here. F of 0 is equal to 0, and we want to find f of 3. So first, we find the antiderivative, which is the function that if you take the derivative of it, you get back to this function here. So it's a little bit tricky to think backwards at first. So we already mentioned that the antiderivative of the secant squared would be the tangent of x, because the derivative of the tangent of x is the secant squared of x. And then we can use the power rule on this one, raise it up, divide by 3, add a constant. So this is 4 tan x minus 2x cubed plus c. Now we can use our initial condition to find out what c is. F of 0 is equal to 4 tan 0 minus 2 times 0 cubed plus c, and that's supposed to be equal to 0 according to our initial condition. So this is going to be 0 minus 0 plus c equals 0. So in this particular case, c is equal to 0. So our function is just f of x. Our antiderivative function is 4 tan x minus 2x cubed without a constant. So now we can evaluate f of 3, which is 4 tan 3 minus 2 times 3 cubed. So putting that into your calculator in mode radians, you would get negative 54,5702. Now in this problem, our starting point is f double prime. So we can take the antiderivative to get back to f prime, and then take the antiderivative of f prime to get back to f. In this case, we need two constants. For each time you take an antiderivative, you need a constant. So if we need to go back twice, we need two constants, which means we need two initial conditions. We need one for f prime, and we need one for f. And then we're asked to evaluate f of 1 once we find our function f of x. So we start out by saying f double prime is equal to 8x minus 2. Then we go back to f prime. All right, so notice the difference in notation. I'm not using the capital F here so that I can keep track of my primes. All right, so I'm going back to f prime. So I'm going to raise it up by 1, divide by 2. This is just going to be an x, and then I'll have a constant. All right, so my initial condition for f prime says that f prime of negative 1 is equal to 5. So f prime of negative 1 is equal to 8 let's just make that 4, times negative 1 squared minus 2 times negative 1 plus c, and that must equal 5. So that's 4 plus 2 plus c is equal to 5. So that's 6 plus c is equal to 5. So c is equal to 5 minus 6. So c is negative 1. All right, so that means f prime of x is equal to 4x squared minus 2x minus 1. All right, we've got our full f prime of x because we had that initial condition to help us out. All right, now we're going to get to f of x by taking the antiderivative of f prime of x. So using the power rule for antiderivatives, raise it up, divide by 3, raise it up, divide by 2, raise it up, divide by 1, doesn't do anything, plus c. All right, so that's f of x is equal to 4/3 x cubed minus x squared minus x plus c. So now I need to use my initial condition for f of x, which was f of negative 1 is equal to 10. F of negative 1, so that's 4/3 times negative 1 cubed minus negative 1 squared minus negative 1 plus c, what did we say, 10 is equal to 10. All right, so that's negative 4/3, so that's negative 1 plus 1 plus c is equal to 10. So these will cancel. So we'll have c is equal to 10 plus 4/3, which is 34/3. So now we know our function f of x is 4/3 x cubed minus x squared minus x plus 34/3. And if we want to evaluate that function at 1, we'll be able to find f of 1. So f of 1 is equal to 4/3 minus 1 squared is 1 minus 1 plus 34 divided by 3. So if we plug all that into the calculator to make it easy, we can get 10.667. And that's what we were asked to find, f of 1. So in this next problem, we've got a trig function involved. So we need to go from f double prime to f prime to f and then evaluate f at 3. So we're going to start out with f double prime. So f double prime is 3x minus 2 sine of x. So taking the antiderivative of that will get us back to f prime of x. So power rule, raise it up by 1, divide by 2. Now we know this is going to be some kind of cosine, but let's think about the sine here. If I'm taking the derivative of the cosine to get back to the sine, and it has to be negative, the derivative of the cosine is negative. All right, so if this is negative, that's not going to work. So I got to make this positive. All right, so the derivative of 2 cosine of x would be negative 2 sine of x. All right, so now I need my c. Now I look at my initial condition so I can figure out what that c is. It says f prime of 0, so that would be 0 plus 2 cosine of 0 plus c, and that must be 5. So we know cosine of 0 is 1, so that means 2 plus c is equal to 5, so c must be 3. So now I know that my full function f prime of x is 3 halves x squared plus 2 cosine of x plus 3. All right, now I'm going to find the antiderivative of that, and that'll give me f of x. So power rule first, raise it up, divide by 3. And then we have to think again here. So I know it's going to be a sign, but let's figure out whether it's positive or negative. So when you take the derivative of the sign, you get the positive cosine, so we don't have to do anything to the sign here in order to be correct. The derivative of this will be this. All right, so then we'll have plus 3, raise it up to an x, plus c. Now, in order to find that c, we need the initial condition for f of x. So f of 0, so that would put this at 0. We know sine of 0 is 0. 3 times 0 is 0. Plus c must be 2. So that means c is equal to 2 for the f function. So simplifying the f function, I'll have, let's cancel these 3's here. I'll have x cubed over 2 plus 2 sine of x plus 3x plus 2. And the last thing we need is to find f of 3. So we'll substitute 3. So we'll get 3 cubed divided by 2. 2 sine of 3, in radians of course. 3 times 3 plus 2. So if you type that into your calculator, you should get 24.7822. Okay, here's another one similar to that, starting with an f double prime and going down to, in this case, we're not evaluating f of x, we're just finding f of x. But the difference here is that I've got an e to the 2x. All right, so first we're going to find, we'll start with f double prime of x. And we'll take the antiderivative of that to get f prime of x. So this one requires raising it up to 2, dividing by 2. Now here's where we always have to think about the sign going from between sine and cosine. So I take the derivative of this right here, the negative cosine. I won't get the negative sign. I'll have to put a positive here. All right, and then also I've got this 2 right here. So because of the chain rule, I would have had to multiply by 2, which means I'm going to have to divide by 2 here. So what we want to do is we want to check this. We've got 4 cosine of 2x. If I take the derivative of that, I need to be able to get negative 8 sine of 2x. Right, so the derivative of the cosine is the negative sine. And if I multiply using the chain rule, you can see that I will get negative 8 sine of 2x. All right, so because of the chain rule, I had to divide by 2. So you always want to use your knowledge of derivatives while you're working antiderivatives to make sure you don't forget anything. All right, and then the last term, I've got 4 e to the 2x because the derivative of e to the x is e to the x, and the antiderivative of e to the x is e to the x. But I've also got that chain rule thing going on, so I've got to divide by that 2. And I can check this as well. If I take the derivative of 2, 4 divided by 2 is 2, e to the 2x, will I get this here? So I can see that I will, because the derivative of 2e to the 2x is 2e to the 2x times 2, which is 4e to the 2x. All right, so I'm checking as I go. You make sure you do that and you won't mess up. All right, now plus c. All right, now I need to apply my initial condition for f prime to figure out the c. So f prime of 0, so this term would be 0. This would be 4 cosine of 0, which is 1. This would be 2e to the 0 plus c, and this has to equal -6, we're told. So this is 4 plus 2 times e to the 0, which is 2 times 1, which is 2, plus c is equal to -6. 6 plus c is equal to -6. That means c is equal to -12. Now we can say we know everything about f prime of x. So that would be 10 divided by 2, 8 divided by 2, 4 divided by 2, minus 12. All right, so next we're going to take the antiderivative of f prime to get f. So raise the power by 1, divide by that same number. All right, so here we go again with the cosines and the sines. All right, so I like to think about, if I take the derivative of the sine, will I end up with that? Well, I've got that 2 I got to worry about again. So I'm going to have to divide that by 2. Now, if I take the derivative of 2 sine of 2x, will I get 4 cosine of 2x? Well, the derivative of the sine is the cosine, and by the chain rule, I will. All right, so I had to divide by 2 there in order to get this to come out right because of the chain rule. Now I'm going to have to do it again here, and we already went through why we had to do that in the prior one, so we'll just divide by 2. Now this one, multiply by x, and then constant. All right, so we've got f of x, 5/3 x cubed, 2 sine 2x, e to the x, minus 12x plus c. All right, so initial condition for f of x says f of 0 equals 4. All right, so f of 0. So this would be 0, this would be 0, this would be e to the 0, which is 1. This would be 0. And what did we say it was? 4. So we have 1 plus c equals 4. So that means c must be 4 minus 1. C must be 3. So that means f of x, we know everything about it now. 2 sine of 2x plus e to the x minus 12x plus 3. Wait a minute, what happened to my 2? I got a 2 here. Alright, so that's it. In this problem, we weren't asked to evaluate f of x. So this is our final result. So our last example here has to do with rectilinear particle motion. So it says a stone is thrown straight up from the edge of a roof 500 feet above the ground at a speed of 15 feet per second. The acceleration due to gravity is negative 32 feet per second squared. How high is the stone 2 seconds later? At what time does the stone hit the ground? What is the velocity of the stone when it hits the ground? So our starting point is the acceleration. So we know that A of t is equal to negative 32. We'll leave the units off. So if we take the antiderivative of A of t, it should bring us to V of t, because the derivative of V of t is A of t. Therefore, the antiderivative of A of t is V of t. So I'd get negative 32t plus c. Now I have to find my initial conditions for velocity. So my initial condition for velocity says that a stone is thrown straight up from the edge of a roof at a speed of 15 feet per second. So what that's telling us is that he's starting out with the stone is going to be at 500 feet. It's going to go up and then down, but it has some initial velocity propelling it up, and that's 15 feet per second. So that means V of 0 is equal to 15 feet per second. So that helps us to find C here. So negative 32 times 0 plus C is equal to 15. So that means C must be 15. So our velocity function is negative 32t plus 15. All right, now from there, if we take the antiderivative of the velocity function, we'll get the position function, because the derivative of the position function is the velocity function. So we go up in the power and divide by that number, go up in the power, and then add a constant. So I have S of t is equal to negative 16t squared plus 15t plus c. Now I need to figure out the constant for my position function, and that has to do with the fact that the position at time 0 is 500 feet right here. So this is my s-axis. This is my time axis. So when time is equal to 0, my position is just starting out at the top of the roof. So S of 0 is 500 feet. So now I can figure out what C is. S of 0, so if I put 0 in here, I'll get 0 here, 0 here, and this must be 500. So that tells me that my C must be 500. So I know my entire position function now, S of t, is negative 16t squared plus 15t plus 500. Now, what we did before was we started here, we took the derivative of this, and we got to this, and then we took the derivative of this, and we got to this, and that you can see that that's going to be the case here. All right, so everything looks good so far. Now the question is, how high is the stone 2 seconds later? All right, so this is our function that'll tell us the position of the stone. So we would just substitute 2 into the S of t function and find S of 2. All right, so that would be negative 16, 2 squared, plus 15 times 2 plus 500. And that comes out to be 466 feet. All right, so that's the position of the stone 2 seconds later. So it's past its peak, and well, it may be rising up to the peak. We don't know when that occurs, but regardless, at 2 seconds, it's at 466 feet. All right, now let's see what else we're asked here. At what time does the stone hit the ground? So that's over here. When the position is equal to 0, when the position is 0, we want to figure out that time. So that means we want to set the position function equal to 0. All right, so that's S of t is equal to 0. All right, so S of t is negative 16 t squared plus 15t plus 500 is equal to 0. This is going to require quadratic formula. So I'm just going to take my negative out here, divide through. All right, so that means t is going to equal to 15 plus or minus the square root of 15 squared for 16 times negative 500 divided by 2 times 16. All right, so if I run that through my calculator, I end up getting that t is equal to either 6.07854 or negative 5.60979. All right, so we know already that we're not talking about negative time here. So that means this is what we're looking for. This is the time when it hits the ground. All right, so that answers the question for B. The stone or the rock hits the ground at that time. This prior answer was the position at 2 seconds. Okay, so one more question. The last question says, what is the velocity of the stone when it hits the ground? All right, so we need our velocity function. So v of t is equal to negative 32t plus 15. All right, and we already know from the last part B that the time when it hits the ground is 6.07854 whatever. 6.07854. So I just sub in that number for t. So then I plug all that into my calculator, and I get this number here. That's my velocity when it hits the ground. Okay, so that takes care of this question. So we've covered the basics of beginning level antiderivatives, and our next part of Calculus 1 will focus on antiderivatives. So we have enough to get started on our homework. Go ahead and get started and let me know if you have any questions.